hello, this is 121. We're going to do the normal curve today. Okay, I got to open the paint window. Okay, this is Math 121, the normal curve. Okay, it's any set of data could be skewed left or skewed right. Okay, if it's skewed right, all the data are bunched up on the left hand side and there's nothing on the right. So that's called skewed right. And then skewed left is just the opposite. All the data are bunched up on the right hand side and there's nothing on the right. So that's called skewed left. And then a normally distributed set of data is just normally distributed. Okay, that's equals that's amount of data all throughout the distribution. Okay, and there's an empirical rule that says all the data, let's see, empirical rule says 68% of the data falls within one standard deviation of the mean. One standard deviation of the mean. And then 95% of the data falls within two standard deviations of the mean. And then 99.7% of the data falls within three standard deviation of the mean. So you have a normal curve where you have 68% of the one standard deviation of the mean. And then 95% is two standard deviation of the mean. So you subtract 68 from 95 divided by 2, which will leave you 13.5% from 1 to 2 standard deviations of the mean. And then you have from 2 to 3, it'll be 99.7 minus 68 divided by 2, it'll be 2.35% of the data. And then 0.15% is here, and 0.15% is here. Let me get a working calculator here. Okay, you have 99.7 minus 95 divided by 2. Yeah. So, anyway, you have to memorize that data. Okay, because that will be not given to you on the test. You have to know those percentages. Okay, that was called the empirical rule. Now they teach z-scores on this in this book that I use, but I normally don't use z-scores in this class. So one example I do in this course is this one. Intelligence scores are normally distributed. With a mean of 100, and a standard deviation of 15. Determine the percent of individuals with IQ scores below 115. Okay, so that's 115 minus 100 divided by, no, don't worry about that. We're not going to do that. Okay, below 115. Okay, so here's the graph I gave you. Okay, the mean is 100. 115 represents a standard deviation above the mean. 2 standard deviations, 130. 3 standard deviations, 145. 1 standard deviation below the mean is 85. Subtract 15, you get 70. Subtract 15, you get 55. And then you have 68% of the data is here, which is 34%, 34%, 13.5%, 13.5%. And this is 2.35%, 2.35%, and then 0.15%, and 0.15%. Now, what percent of the scores are below 115? That'll be all these percentages added up, which is what? 34 plus 34 plus 13.5 plus 2.35 plus 0.15, which gives you 84%. 84% of the data are below 115. Okay, below 130. Okay, we do the same graph. Here's the mean, which is 100, 115, 130, 145, 85, 70, 55. Okay, below 130, be all those percentages there. And you have 34%, 34%, 13.5%, 13.5%, 2.35%, and 2.35%, 0.15%, and 0.15%. Okay, the numbers below 130 will be all these percentages from here on added up, which is what? 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15. And that's not right. 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15. Okay, 97.5%. And now what about between 70 and 115? Okay, 13.5 plus 13.5 plus 34 plus 34 is 95%. Okay, so that's how you do that one. Okay. Okay, on this problem, assume the mathematics scores on an SAT test are normally distributed with a mean of 500 and a standard deviation of 100. Okay, what percent of individuals who took the test score below 550? Okay, below 550. Okay, so you got your graph. The mean is 500. So here's where the average is. The standard deviation is 100. So you add 100 to 500, get 600. Add another 100, you get 700. Add another 100, you get 800. And these are scores below the mean. Subtract 100, you get 400. Subtract the mean, you get 300. Subtract 100, you get 200. And who scored below 550? Okay, we'll just say score below 600. We'll make it 600. Okay. Now this is the mean. So it's 34% here, 34% here, 13.5%, 13.5%, 2.35%, 2.35%, 0.15%, 0.15%. Below 600 is 34 plus 34 plus 13.5 plus 2.35 plus 0.15 is 84%. what about between 400 and 700? Okay, the mean is 500. The mean's the standard deviation is 100, so you have 600, 700, 800, and then this is below the mean, 400, 300, 200. And here you have 34% of the data on both sides of the mean. 13.5% here, 13.5% here. And then 2.35% here, 2.35% here, and then 0.15% and 0.15%. Okay, between 400 and 700 is these percentages. 34% plus 34% plus 13.5, which is what? %81.5%. Who scored below 200? How many scored? Or what percentage scored? What percent scored below 200? Okay, so here's the mean. The mean was what? 500. Standard deviation is 100, 600, 700, 800, and then below the means 400, 300, 200, and you have 34% here, 34%, 13.5%, 13.5%, 2.35%, and 2.35%. 0.15% and 0.15%. Okay, and so the percentage below 200 would be 0.15%. And if you have 600 people took a test, it would be 0.15% of 600. And 0.15% is 0.0015. So that's 0.9 people. So I would say around one person. Okay, so that's what you call the normal curve. Okay, now assume the speed of automobiles. Automobiles is normally distributed with a mean of 62 miles per hour. 62. With a standard deviation of 5 miles per hour. Okay, remember, standard deviation is 5 miles per hour. Okay, what percent of cars are less than 62 miles an hour? Okay, between 52 and 67 miles an hour. Okay, here's the graph. The mean was 62 miles an hour. The standard deviation is 5, so 62 and 5 is 67. 67 and 5 is 72. 72 and 5 is 77. 62 minus 5 is what? 57. Minus 5 is 52. Minus 5 is 52. 52 minus 5 is 47. Okay, so you have 34% of the data is here. 34% of the data is here. 13.5% is here. 13.5% is here. 2.35% here. 2.35% is here. And 0.15% is here. And 0.15% is here. And so what percent of the data are lower than 62 miles an hour? It's 50%. And between 67 and 47, between 42 and 67. 47 and 67. It'll be 2.35, 13.5, 34, and 34. Okay, between 47 and 67. 2.35 plus 13.5 plus 34 plus 34. 34 plus 34 plus 13.5 plus 2.35. It'll be 83.85%. Okay, now that's all to this video for today. I'm going to stop this recording and I'll put this on YouTube. And if you have any questions, you can let me know. Okay, I'll talk to y'all later.